Hi there, this is Nick at opennet.io, a project of OpenSpace, the new hackerspace in Milano, Italy. So for those of you who don't know the project, OpenNet is a mesh network that will eventually span the entire city here in Milano. And to do that, we're going to use a lot of internet connections that are going to be crowdsourced from all the hosts, which are going to be the users who not only will use the network, but they'll also share their home internet connection with the network. This way, we will have distributed internet provided to the network, and we will have to protect our users by setting up VPNs. So basically, all the traffic that will be coming from inside the network will have to exit the network through these hosts nodes. So basically, these nodes will be connected to the host's internet connections, the ISP routers, but instead of having the traffic go straight out from their IP address, so without any anonymization, we will have all the traffic going out through VPNs. So the hosts will be protected, their IP addresses will not be exposed, and they will not be associated with the user's activity inside the network. So let me stress from the start that VPNs do not provide anonymity. VPNs are just a layer to take the responsibility off the hosts. Every client device on Earth should always have a level of anonymity installed onto it. So VPN, always on VPN, Tor, I2P, anything you want. But since we cannot trust the clients to always have VPN on, and this will never happen probably, we need to protect the hosts by ensuring that all the traffic coming from inside the network before going out of their ISP router gets routed through a VPN so that their IP address is not associated with any of the user's activity. In Italy, at least, it's 100% legal to share your internet connection, so you don't have to worry about this if you're thinking of becoming a host, but it's important to know that you will be protected and your IP address will not be exposed. So basically, we have a bunch of VPN servers running here on VPSs in Italy. We have a very cheap provider providing us with very high traffic in and out. And we can give you links for that. You can find them in the description. In an event, we have remote VPN servers that are really close to us. They're in Arezzo, which is a city pretty close by to Milano. And the IP addresses, of course, are Italian, so users should notice the difference when browsing websites that recognize your IP with GeoIP and adapt the language of that website. They will see the website in Italian for us. The latency is really low because these servers are really close to us. So they add, in our experience, about 10 milliseconds of latency. So if you're on a fiber connection, you'll probably experience 4 millisecond ping to google.com. With our VPN service, you experience about 16 milliseconds. It is noticeable, but for most applications, it's negligible, and the speeds are really high with our routers. With our VPN routers, we can achieve 120 megabits per second up and down of speed, and with L2TP with IPsec. Now, L2TP with IPsec is a VPN protocol. It's not the most secure. OpenVPN is definitely more secure. The cryptography is much stronger, but it is also much harder on the router's CPU. So we need to find the right balance between security and convenience. So in our experience, router boards, Microtik RouterBoard HEX routers work really well. We've been using them for a while now. Let me just point out that the software running on them is not open source. It's called routerOS. It's proprietary, but for us, for now, until we find a better solution, it's a very good trade-off. And we have been experiencing really high speeds and 100% stability. The VPN never breaks. If the ISP router goes down for any reason, the router reconnects to it automatically. If we reboot the VPN server, So for testing purposes, since the server never goes down on its own, if we actually reboot the VPN server, the router OS will not fall back to normal internet connection. So it has what we call a persistent tunnel in OpenVPN terms. So it will not fall back to not anonymizing the traffic. The user will experience downtime for those 20 seconds it takes the server to reboot, but that protects the host. And again, the server should never go down on its own. It's only gone down in our experience when we were testing out and trying to intentionally break the connection to see what the router would do and how it would handle the reconnection. So this is a how-to on how to set up L2TP plus IPsec protocol VPN on routerOS running on Microtik HEX router. Now for VPN, the protocol in fact we're using is L2TP plus IPsec, but the server itself is a Streisand server. Streisand is an open source project on GitHub, and basically in just 1 or 2 commands it will set up for you on a very high level, highly audited and secure environment to connect to your remote server via VPN, Tor bridge, or other technologies. This basically provides multi-technology anonymity, and it is really cool because it's really easy to set up. You can self-host it. We like self-hosting things here at OpenSpace and OpenNet alike. Of course, we're not self-hosting it on our servers physically in our spaces because they would have the IP address associated to us from our ISP, so that would defeat the purpose. So we're using remote servers on our cloud hosting provider. Now, Streisand is really easy to set up, and I'll also do a video on how to set it up in a future episode. But for now, let's just assume that we have a running instance of Streisand. We have one right here. It's really easy once you set it up to have the credentials. And for now, if you connect to your Streisand instance, you use your credentials that it spit out to you when it first got set up. You can see the home page. Now we will choose the L2TP with IPsec protocol, and we will just click Linux because we have a bias towards this operating system. It's really the same, it just needs to give us the credentials and the IP address. So basically I just unboxed my new HEX router. I connected it to the power and connected the first port, also numbered 1, internet, it says internet, and to my ISP router. And I connected my computer to LAN port number 2. I guess you could connect it to any other port because it's already set up to have all 4 LAN ports the same, but I just connected to number 2 in case default software changes in the future in routerOS. So now if I go on my system preferences, I'm using Mac today, sorry about this, but this is what we have handy. So I can see that I'm connected to my router because it says 192.168.88.1, so that's a signature of routerOS in this case. So we'll just connect to our router here, and we will see the webfig, as they call it. So let's wait for it to load, and there it is. So let me just give you an overview. It is really complicated, as really cluttered. There's a lot of options. You can basically customize anything you want. Don't get scared. I'm going to walk you through this. We're not going to have to change a lot of things. It's going to be pretty simple. So first of all, let's do some customization. So of course, I'm going to show you how we set routers up in our environment here for OpenNet, but you can either do the same or customize a few details. We like to assign 172.16.00 network IP addresses to these VPN routers. This way we can easily identify these devices on the network and we know exactly what we're talking about. So I'm going to go ahead and give this router an IP address of 172.16.0.1, and the net mask is going to be 12. That's just because how the standard is. Now also make sure to change the DHCP server range. It's going to be from 172.16.0.101 for our configuration to 172.16.0.254. Make sure NAT is selected, and let's give this router an identity. So for us it's going to be opennat.nixno, which is me, and I believe our nomenclature for these is Microtik HEX, and this is router number 3 for us. We can give it a password. Make sure you do. I'm just not going to do it right now for simplicity, but make sure you do give it a strong password. So let's apply the configuration here. Make sure everything is correct. Yes. So the router is going to acquire an IP address for itself from your ISP router with DHCP on the ISP router side, and it's going to set its own network to 172.16.0.0, and it's going to send itself 172.16.0.1. Okay, so we have clicked apply configuration, and after that I've just disconnected my Ethernet cable from my computer to my HEX router just to make sure that the computer acquires a new DHCP lease, otherwise it's not going to work. So let's go ahead and reconnect the Ethernet cable to my computer, and it should acquire a new DHCP lease from the freshly rebooted HEX router. Let's just give it a second there, and yes, there we go. So if we go back on our browser, we type in 172.16.0.1. We enter our password if we set one up before, and we wait for it to load. Now at this point we can go ahead and set up our VPN connection. So we are going to go in PPP, and we're going to add a new L2TP client. That's because the server is in the cloud, and the HEX router is going to act as a VPN client, and all the traffic that it is going to go through this router is going to get forced through the VPN. So there's no way the traffic can not go through the VPN. We can't do anything wrong, can't mess things up. At a hardware level, anything plugged into the router will go through the VPN. So we can rest assured. Our mesh router, which we'll talk about in another video, is going to be plugged in on the LAN port, on one of the LAN ports of the HEX router. This way, its WAN is going to be the VPN. If you take a look now on the Streisand page, we see the details we need here to actually set our VPN client up. So let's go on the webfig and give the VPN a smart name, so like this for our VPN. Now for Streisand instance, we have experienced that if we don't set 1280 as the max MTU and MRU, packets get fragmented. Not exactly sure why, but this is just how it is. So you can also just leave it as it is and see if it works for you. In our case, we just set it to 1280 and rest assured that it works. You can search Google for packet fragmentation test. It'll have you type in a ping command, and you'll be able to check on your own if packets are getting fragmented. If they are, just come back here and set 1280, or just set it to 1280 from the start, as you prefer. So we are going to connect to our IP address, which we're going to copy here from the Streisand page. The user is going to be Streisand, and we are going to copy the password from Streisand and click the little arrow here on the webfig so that the text box shows, and we are going to paste it in. Now make sure to check use IPsec, which is the encryption layer on our VPN connection, and paste in the IPsec secret, which is called IPsec pre-shared key on Streisand. It's the same thing. Now just make sure you select allow fast path, dial on demand, and add default route. This could not be a correct configuration, especially without setting default route distance or any other thing, but it works for us. If you have any better ideas, just let us know in the comments. Now if you go and press apply, you should see the status as connected and the status is running. So we can press OK right there, and now we can open up the window and go on IP and press firewall. Now the router has connected to the VPN successfully. We just have to tell it to route all the traffic from the LAN to the VPN, otherwise it's useless for us. So we're going to go here in IP, firewall, NAT, and click add new rule. Now SRC NAT is going to be our chain. We're going to go down in out interface and select our newly created VPN interface. Then if we scroll down under action, instead of accept, we're going to set it to masquerade. That's all we have to do for now. We are going to click OK. And now we're going to go up to Mangle, the other tab, and also add new. Chain is going to stay to pre-routing. That's okay. We are going to set the source address as all the IP addresses that represent clients that of which the traffic should go through the VPN. So in this case, it's 172.16.0.1 because we want the router to go through the VPN itself as well, and up until 172.16.0.254. That's good enough. We can go down and under action, this time we select mark routing. We're going to assign a new routing mark. We're going to type it in. We're going to call it VPN. Make sure you type it in. You can call it anything you want. We'll call it VPN, and we'll press OK. So now we're going to go on IP routes. Going to add a new route. Destination address is going to stay what you see, 0.0.0.0/0. The gateway is going to be the VPN. So press that down arrow and select our VPN instance, and down on routing mark, make sure you select VPN or whatever you called it. Now let's press OK, and we should be good to go. So without having to reboot or anything, just open a new tab and go on ipinfo.io. So this is the IP address of our VPN server, and we are, for all intents and purposes, a client on the HEX router, which means that our configuration works. You can stress test it by restarting it, restarting the ISP router if you want. Make sure that everything works as desired. You can also use the terminal application on your computer to do some testing. So for instance, now we can ping google.com and see that the ping right now is 20 milliseconds, slightly higher than usual, but it's still very good ping. And you can also go on a website such as speedtest.net and check for yourself that the HEX has indeed a really high processing power and can handle the crypto for VPN connections very well. So in this case, you'll see that our speeds are well above 100 megabits per second and easily reach 120 basically every single time. Don't mind the upload speed because my fiber connection is limited to 30 megabits per second, so it's going to reach that and nothing else. But if you did have 120 megabits per second in upload speed from your ISP, your hex would easily reach it with no problems at all. Now, the DNS settings for you might vary. For us, we keep them default. The hex handles DNS very well. Nothing broke ever in our experience. And basically, this is all you need to do. You can check the VPN status clicking on PPP. You'll see packets going up and down, in and out. If you double click on it, you should be able to see a graph right here. Yeah. It'll show you the uptime. So that's important. It will tell you how often the VPN breaks, if it ever does. And in our experience, it has never broken, at least noticeably. The stability for us has been extreme. Let us know if it's not the case for you. Just for your curiosity, 192.168.32.1 is the IP address that Streisand assigns to itself after you set it up. So if you want to see how long it takes for a packet to reach your VPN server, you can easily ping 192.168.32.1, and you'll see it takes 11 milliseconds for us, which is very good. Make sure that's always low, because it means that your VPN server is close to your mesh network location, or for other purposes, to your client, basically, so to your hex router. That will ensure you have very good experience with your internet connection. And yeah, so that is all for now. If you have any issues, just let us know. If you have any suggestions or corrections, we're here to listen. We learn everything by doing stuff, so we might get things wrong, and definitely we do sometimes, but we're always here to improve and work together on everything. That's the spirit. So thanks for watching, and I hope to have inspired you with your mesh network project if you're working on one. If you are interested in OpenNet, please visit us at opennet.io. The website is under construction at the moment. If you are around the area, Milano, Italy, please visit us at OpenSpace, the new hackerspace in Milano. There's a lot of stuff going on. We're just starting up right now, but it'll be very, very cool in the very near future. So thanks again for watching, and have fun.